Hi folks, good morning. How are you all today? I heard some hellos. Did Donovan make you do the hello thing this morning? You know, where he says hello and he says he didn't hear you and makes you say hello louder? No? No? Ah. My name is Edward Thomson. I'm a program manager at Microsoft, and today I want to talk about continuous integration. In particular, I want to talk about continuous integration using Azure pipelines and how we can get some more advanced and more modern continuous integration approaches using that. Real quick about myself, I'm a program manager on the Azure DevOps team. Right now I focus on continuous integration and continuous delivery. So primarily within Azure pipelines, especially enabling open source projects to bring their builds over and to validate that pull requests are good and that the health of their open source project is high. Before I did that, I was actually working on Git. So my background is in version control before that. So primarily within Azure repos and then at GitHub before that as well. If you're not familiar with Azure DevOps, so I guess if you missed Donovan's keynote earlier, Azure DevOps is the refinement of a product that we used to call Visual Studio Team Services. Before that, we called it Team Foundation Server. And the idea behind Azure DevOps is that it's a set of developer tools for you to use to enable your productivity. In other words, it's a set of tools to help you do DevOps better. And there's no such thing as enabling a tool to let you do DevOps. If you just grab Azure DevOps, you're not going to suddenly do DevOps. I wish that were true. I wish I could build a tool that made you successful with development, with operations, with the whole DevOps methodology, but I can't do that. Because DevOps is more than just a tool, despite the fact that we named it Azure DevOps. We named it Azure DevOps because we want it to help you with your DevOps, but it is not DevOps alone. Because DevOps requires three things. It's the union of people, process, and products to enable continuous delivery of value. So you have people, you have engineers, you have ops, and you can have a product like Azure DevOps to help you on your journey to DevOps, but you also do need these processes. So I don't want you to think that this is going to, without changing your processes, bring you to a more successful DevOps or a more successful continuous integration strategy, right? These will help you, but they are not it alone. So again, we used to call this team Visual Studio Team Services. Now it's Azure DevOps, and we've split it up into several different components. So we've got Azure boards for your planning, we've got Azure repos for your version control system, and then we've got Azure pipelines. So Azure pipelines is now a standalone product that you can use for continuous integration and continuous delivery. And that was really the reason that we split these products up into the Azure DevOps family, so that you can use Azure pipelines for your CI and CD build systems, even if you're not using our version control. So if you're using GitHub, if you're using Bitbucket, if you have a Git repository server hidden under your desk, please don't do that. Please don't store critical infrastructure under your desk. But if you do, that's fine too. We can actually build out of that and release out of that. And that was really the goal in moving to Azure DevOps and splitting these services up, was so that we can allow you to enable it even if you're not using the rest of the suite. So you can use Jira for bug tracking, you can use GitHub for your version control, and then you can still use Azure pipelines. We've made really significant investments in the CI and CD space over the last few years. And so I'm really excited about what we have in Azure pipelines. So first of all, we have a modern CI infrastructure. So what that means is we support using YAML. If you If you haven't played with the build infrastructure in a couple of years, you might remember, a nice pointy clicky interface to configure your builds. We still got that. If you like the pointy clicky interface, that's great. But we strongly encourage you to go add your build definitions as YAML. YAML is just a build description language. It's just a text file. It actually stands for yet another markup language because as engineers, we're bad at naming things. But the idea behind YAML is that you can check that file in that describes your build right next to your code. So you actually check in the way your code gets built. And that's really, really useful. Because as your code evolves over time, let's say you're shipping an on-premises, a box product, right? You've got a version 1.0, you ship it on a CD. Let's pretend it's 1995 for a second. Having that build description checked in as YAML allows you to define how version 1.0 got built. And then, as you evolve version 2.0, as you evolve your code, your build changes too. And so you can actually update that YAML and check it in to reflect the code that you're building at any point in time. So now, let's say somebody comes along and has a bug in version 1.0 that you need to go fix. You need to hotfix it, right? So what do? You git checkout v1.0. And with YAML, you now still have, you get checked out, the build description for version 1.0 as well. In ye olde days, back before we checked this in, we would have a build server that now knew how to build the newest version of the code, but we'd have to try to remember how to make it build version 1.0 again, because dependencies had changed, we'd added new things, we'd added new build scripts, and it was just a big pain. At Microsoft, we actually employed people. Their full-time job was to remember and configure how to build various versions of the product. You want to build a version of Visual Studio 2015? There is one person who remembers how to do it. He is handsomely paid because his job is not easy. But hopefully we can get that information out of his head. It's a guy named Lauren. Lauren's a great guy. I want to take that information out of his head and put it in YAML instead, so that not one person remembers how to do it. The builds themselves describe how things work. So let's actually take a look at what this, in fact, looks like. All right. So this is Azure DevOps. So right now, I have a project here. It's a really, really simple project. It's a web app that says, hello world. There it is. It's in fact the simplest web app. Well, actually, that's not true. It's actually a little bit complex. Let's come into the code. This is Azure repos. So this is my code in a Git repository. And what I actually have is a .Net Core application with Razor pages. It's all very, very fancy. It's way overly complex. I think the only way that I could have made a hello world more complex was by using Java. Let's pop over here. There we go. And if I actually look at the code, what I've got is a Docker file there. And so what this does is it takes the .Net Core Docker image and uses that as a base and builds my application on top of it. So if I Docker build that, I get a container and I can Docker run that. There we go. And here in my local repository, I've made some changes, right? If I pop back over here and look at what's in production right now, not real pretty. I know a little bit of HTML and a little bit of CSS, not very much, but I can improve upon this. And there we go. It's a little prettier. It's at least not black on white. And it says hello to y'all. So that's nice. So how do I actually get this into production? Well, let's build a build pipeline for it. there we go, build a build pipeline for it. So again, if I go back to Azure repos, to my code, the first thing that you see here in the top corner is setup build. So Azure DevOps is actually trying to lead me through best practices so that I can actually set up a modern sort of CI and CD system from my code. So let's go ahead and click that. And the first thing it wants me to do is configure my pipeline. So what it's going to do is it's actually going to look at my code and try to figure out what I'm building to try to give me some steps through. And right up at the top is ASP.NET. So it's actually analyzed my repository and decided I'm building an ASP.NET project, which I am. But and let me go ahead and click on this just to illustrate this. So this will create some YAML. So this will basically set up some best practices for a .NET, ASP.NET build using YAML. And so I can just click save and run, and it'll go ahead and build this, run my tests, all that stuff. And that's very handy. But what I actually want is to do a Docker-based build. So I've got that Docker file. What I actually want to do is build and deploy with containers. And so that's something that we've actually added sort of recently, is the ability to identify Docker files as well and walk you through an experience that is a Docker-based build and then a deployment of that container. And so what I actually want to do is enable some preview features. If you're an Azure DevOps user, so we ship every 3 weeks. We ship new features every 3 weeks. And often we hide them. We hide them up there in preview features. And so we can turn them on, first of all, for ourselves from Microsoft. We just flip a feature flag on for ourselves so that we can test it. We turn it on for MVPs next. And then we open it up to you. So we can go into preview features. And the one I want to enable is called multi-stage pipelines. Now, that is a really kind of dull name that doesn't really get across what it's doing. It's actually the entire new, the next iteration, the next step of our continuous integration build and deployment experience. So it takes YAML to the next level. So we started with Visual Designer, which was all just pointy clicky, which is fine. You know, it's very easy to set up. The next step was YAML, which allows me to do that configuration as code that I was talking about, lets me check in my YAML that describes my build to my repository, but it's not super accessible, right? YAML's not easy to write. Like, look at this, you know. You would have to go and actually, you know, read a bunch of docs to figure out what it is. This is the next step where we're actually combining those two ideas. So we're doing configuration as code with YAML, but we're actually bringing in the Visual Designer on top of that. So we're going to have, you can either, if you just want to write YAML, that's fine. But if you want a simpler experience where you don't have to read a bunch of docs, we've got a designer on top of that which will emit YAML. So you get the best of both worlds is the goal. And so here's that. And so part of this new CI, this next iteration, is that it understands Docker containers. So it's going to lead me through a Docker build and a deployment with that container. And when I click on that, instead of just getting a screen full of YAML that I have to edit, over here on the right-hand side, it's asking me questions. So this is the first step of that wizard experience, is walking me through the setup. So what I can do here is basically select an Azure container registry that I want to publish my Docker container to. So it's going to run my build inside the Docker image, inside Docker rather, and then it's going to deploy it to Azure Container Registry. I'll select my subscription, click continue, select my container registry. There we go. It knows the Docker file. And then it's going to actually scaffold up a YAML for me that's customized for my repository and for a deployment even into Azure Container Registry. Now, of course, you don't have to deploy to Azure Container Registry. You could deploy to Docker Hub. You could deploy wherever you want. There we go. So that looks good to me. I can scroll through and check this stuff out, but fundamentally, here's what it's done. It's actually set up a service principal for Azure Container Registry. So it's taken care of all of the hard bits for me. I can click Save and Run. There we go. And that will go ahead and do the build. If we click on that, we can actually see exactly what it's doing. It's going through the steps, checking out my Git repository, running my build within Docker, and then it's going to publish that to the container registry. I actually like watching this stuff, but I'm not going to sit here quietly and make you watch it, in case you don't. So let's come back to that in a minute. In the meantime, what we did here was we came through Azure pipelines. We set up a Git repository that was in Azure repos. So no surprise that Azure pipelines is good at building Azure DevOps projects. I mentioned earlier, though, that we could build code from anywhere, whether that's GitHub or Bitbucket. Let's take a look at that. There we go. Let's pop over here. There we go. So here I've got a GitHub project. It is, in fact, the exact same project. But this time, I want to build out of this GitHub repository instead of out of Azure repos. The absolute easiest way to get started with this, if you are in GitHub, is to use the new Azure Pipelines extension. It's in the Marketplace in GitHub, so I just need to click on Marketplace, search for Azure Pipelines. And I can set up a plan. And the thing that I'm happiest about is that this is free. If you're using GitHub and you are building proprietary applications, closed source applications, it's free. You get a limited number of minutes per month. You get one parallel pipeline. You can grow into that. But there is a free plan. If you are an open source project, however, it is completely free. So you get unlimited build minutes per month for your open source project. You get 10 free parallel pipelines to build that. So you can validate pull requests. You can do CI builds for your open source project, all very, very free. So all I have to do is click a few buttons. And if you're not actually an Azure DevOps user already, what this will do is let you set up a new Azure DevOps account. There we go. I'm going to sign in with my Microsoft account. You could actually, in fact, just sign in with GitHub. This is something we launched a little bit ago. Right after we acquired GitHub, a lot of people said, oh, are we going to have Microsoft accounts to sign into GitHub? Actually, no. Nobody actually likes using Microsoft accounts to sign in. Instead, we went the other way. So now you can sign into Azure DevOps with your GitHub account. A little bit easier. So I'm going to go ahead and sign in. And of course, I have two-factor authentication enabled, which is always fun for a demo. Don't look at that. There we go. And so now what it will ask me to do is either choose an existing Azure DevOps account, which is fine. I've actually got a bunch. Or I can create a new Azure DevOps organization. It'll ask me where I want to put it. West Europe, great if you're here. I'm here right now, but let me select Central US because that's where I'm usually at, in fact. And then go ahead and click Continue. And so this will actually set up an all-new Azure DevOps account for your builds out of GitHub. Again, completely free if you are using open source, and completely free if you're doing proprietary projects with a limited number of minutes as well. And then it'll just walk me through the exact same setup that it did before. I can select my repository. It will suggest a template for me. Again, the current iteration will give me an ASP.NET. I could also opt into the new, just like I did before, and go through the Docker image. I'm going to click Save and Run. There we go. And it's going to kick off a build out of my GitHub repository. So super straightforward to get started out of GitHub. Of course, this could also be Bitbucket. It could be a Git server under your desk. It could be Subversion. So there's nothing tying you to the rest of the Azure DevOps family just because you're using Azure pipelines. Okay. So while that's building, let's pop back over here and see if our build completed. In fact, it did. So this has actually published a new image to Azure Container Registry. There we go. We can scroll down and see that it went ahead and did all of that. That is delightful. And now what I want to do is actually update my site in production. So I can go back to the Azure portal and update that to point to that new Docker image that just got pushed. If you haven't used the Azure Container Registry, it is just, I think, delightful. So here's my container registry. And hello world. Let's zoom in. Aha, there we go. So I've got a bunch of new containers. And I can update this image right here, point it to that new container that just got deployed. And that will go ahead and let's go ahead and restart that as well. Now, of course, the next step here would be to actually set up continuous delivery so that I actually had a release step that did this for me. We'll take a look at that in a second. Whoops, I actually selected the wrong container. It turns out I've done this demo a few times. My bad. I knew it was rough when I just had a bunch of numbers to pick and forgot which one was which. So. But that is basically the way to get started with a Docker-based build. Cool. So I set up this this build out of GitHub over here. One of the biggest advantages to me with using builds out of GitHub is, again, the open source nature of it. Because, again, we give unlimited build minutes for open source projects with 10 free parallel pipelines. And I maintain a bunch of open source projects. Like I said, I came up through version control, so I do some work on various Git open source projects, Libget 2, Libget 2 Sharp, those sorts of things. And for me, as an open source maintainer, one of the most important things about the health of my project is having a CI/CD system that I can trust. So every time somebody sends a pull request, I want to be able to validate the code that they're sending. So I want to build it. I want to run all my tests against it. And I want to run regular CI builds against my master branch to ensure that it is still healthy. And I want to do this on as many platforms as I support. So it's very important to me as a maintainer to make sure that this all works. So here is another one of my open source projects. It is a calculator app. It is, like my Hello World app, it is also ridiculously over-engineered. It's actually a front end with REST APIs. So it actually has REST APIs to do simple arithmetic. So if you ever need to know what 1 + 1 is, you can call my REST API. It's very handy. It is right here. And this is not Dockerized. This is actually just a very straightforward Node.js app. So let me go ahead and npm start that for you, so at least so you can see it. and that's on 3000. There we go. It's just like the pocket calculator you had when you were young, if you're as old as I am. Okay, so none of you remember this, but I do like retro computing. So I can say 4 plus 4 equals, and it gives me 8 back. That's kind of what you expect out of a calculator. And again, this is a JavaScript front end talking to a NPM backend over REST APIs. So what I actually want to do now is go back to this project over here on GitHub, and I want to make sure that pull requests coming into my open source project are vetted, that they run the build and run my unit tests. Because I do actually have unit tests for this to make sure that when you do 1 plus 1, you get 2. It seems simple, but this is programming we're talking about. Let's not make any assumptions. Okay, so what I want to do is go back to my Azure DevOps account, and I want to create a new project. I'm going to call it Calculator, and it's going to be a public project. That way, people who are coming into my open source project can actually see the builds too. I don't want private builds for an open source project. Click Create. And when that finishes, what I'm going to do is go to Pipelines and create a pipeline. So I've already configured this with GitHub, so it's already set up, so it's nice and authenticated. So I can just select GitHub here, and it will show me my list of repositories that I have. I'm going to click on Calculator. I'm going to give it access to that particular repository because you can give Azure Pipelines access to repositories on a repo by repo basis. Just get all those webhooks set up. There we go. And again, it's going to take a look at what's in my repository and try to figure out the best thing for me. Up at the top, it decided I'm a Node.js app, which I absolutely am. So I'm going to click on that, scroll through. If you are a Node developer, you'll recognize this. If you're not, npm install is kind of like it's a package restore. It's similar to NuGet restore or whatever. I depend on other packages, so I need to do that npm install step, which will get my dependencies, and then npm run build, which it's JavaScript, so it's basically a no-op. If this were TypeScript, though, it would do a transpile step or something. I want to add one more step here, and that's npm run test, because I actually do have unit tests, because I'm a responsible open source maintainer. And then I'm going to click Save and Run. And what that'll do is it will check a YAML file into my repository directly on GitHub, and it'll start my build. So if I go back to GitHub and hit reload, I should see that YAML file that it's building. There we go. So again, it gets checked right into my repository. That's configuration as code. That helps me manage my build alongside the actual code that it's building. Okay, and if I pop over here, again, what it's going to do is it's going to do that checkout step. It's going to install my dependencies, and then it's going to run my tests. So let me actually zoom in on here, and we can scroll down, and these are actually my tests. There we go. So that's great. That's exactly what I want. The other thing that it's done is that it's gone ahead and added to GitHub some webhooks. So now anytime anybody opens a pull request against my project, it will run this build. Anytime I merge something into the master branch, it will run this build as well. So let me create a pull request. Let me go back to my code. Let me browse through here. Let's assume for a minute that I am an open source contributor. I've found this project. I've decided what I really need in life is a REST API to do simple arithmetic. And I'm checking it out. Come through here. I don't know how many of you are open source maintainers like I am, sometimes people drop in and they have interesting requests or interesting pull requests for you, because when people jump into a new project, it's hard to get the entire scope of it at once. And so if you come in here and you are perhaps not super familiar with JavaScript, which I got to tell you, I'm actually kind of not, because this looks weird to me. I've got this add function, and what it does is, if you look at the subtract function, that makes sense. It returns a minus b. If you look at the multiplication function, it returns a times b. You get the idea. But the add function looks weird. It doesn't return a plus b. It returns plus a plus b. And that seems really odd. So in fact, let's maybe make a pull request where we change that. So let's edit this file. We can edit it right here in GitHub and get rid of the plus a plus b and just make it a plus b. That looks much nicer, right? That looks like math now. And we scroll down and we're going to create a new pull request. There we go. And scroll down and create the pull request. There we go. Great. And now what will happen is if we come down here, this is the area that GitHub shows its checks. And the first thing it does, and you can see that right now, we've got the green check mark, is it makes sure that there are no conflicts in the code. In other words, that you can actually perform a merge if you click complete pull request, that the code can actually flow through. You don't need to go fix up any conflicts. The second thing it's going to do is turn yellow. And what happens is that it has asked Azure Pipelines to do a continuous integration build to validate that this pull request is good, that it builds, and that our tests pass. Oh, and in fact, it does not. Our tests do not pass. And we can go get more information if we click on the checks area and then go to Azure Pipelines directly. There we go. And now we can click on that job, click on the red area, and scroll down and see, in fact, that things did not work right. If I look here at my errors, well. So what I've done is I have a test that adds two positive integers. In fact, it adds 21 and 21 and expects the answer to be 42. In fact, the answer was not 42, it was 2121. Yeah, that's weird. Types are hard in JavaScript, it turns out. And so what we've actually done is string concatenation with those two numbers. The plus a coerces a into an integer so that it can actually be added to another number as a number instead of as a string with concatenation. So it turns out this pull request is totally bogus, even though it looks good, right? Plus a plus b doesn't seem to make any sense, at least not to me, who's not an expert in JavaScript and type coercion. So I might have been inclined to merge this. And there are a lot of pull requests that you get as an open source maintainer that look good, but might have some subtleties, especially when you start thinking about cross-platform. If you're building on Mac, Linux, and Windows, if you're building on iOS and Android, suddenly things get a lot more subtle, and it makes a lot of sense to validate every single pull request. And this is true whether you're an open source project or just building something within your organization, within your enterprise, within your startup. Okay? So, very, very helpful to always use continuous integration builds and pull request validation builds. Cool. So one thing that I didn't mention here, right? We built a .NET Core app. We built it in Docker. It makes sense that Azure Pipelines would do a good job supporting .NET Core, right? The .NET team is like literally the building next door to us. So I think they would sneak over and hurt us if we didn't do a good job with .NET Core. So we try really hard there, right? No surprise. This is an NPM app, and in fact, it's an NPM app building and running in Linux. So one of the things that Azure Pipelines provides is a number of cloud-hosted build agents for you to use. And again, that's totally free if you're an open source project, and it's free for a limited number of minutes if you're not, if you're a closed source project. But we maintain all these build agents for you, so you don't have to think about it. So in the cloud, in Azure data centers, we have a bunch of Windows machines ready to run your builds. We have a bunch of Linux machines ready to run your builds. We, in fact, even have a bunch of Macs ready to run your build. And so, again, it's very helpful, no matter what kind of application you're building, to be able to do CI. So here's an example of that. Here I have an iOS project. So this is a really simple game that I created. Let's take a look at it. Let me open up Xcode. There we go. And what this is a just a real simple concentration style game with emojis. And what I want to do is make sure that I can actually, hey, I found a match. Look at that. What I want to do is make sure that this builds and that my tests pass. And in fact, I have a test like this one that will make sure that the game is in fact winnable, right? So it will basically solve the puzzle and make sure that at the end that you win. So I don't have any idea how to do that better than just brute forcing it. So if you've ever seen war games, this will look familiar. But the idea here is that I want to make sure that this also stays healthy. And thankfully, Azure Pipelines has a bunch of Macs ready to go, ready to do this build as well. So I'm not limited to .NET applications. I'm not limited to Windows. I can build on iOS apps on a Mac. So let me go ahead and get that set up. Let's pop back to, there we go. So let me go ahead and set up a pipeline here. There we go. Again, I'm going to select out of GitHub. And I'm going to select my repository. And once again, it's going to take a look at what's inside as soon as I actually, allow it to. There we go. So it's going to take a look at what's inside and try to identify a YAML file that will best build this project. So in this case, it's an iOS app. It is going to, there we go, suggest Xcode. So if I look at my YAML, the first thing I notice is that now I'm building on macOS. So that's really cool. And then it's super straightforward to do an Xcode build. I want to change this just a little bit. Instead of doing a build, I've got a bunch of unit tests, so I want to run the test action. Whoops. I want to run the test action instead of the build action. For my scheme, I want to give it my unit test project name. And I want to actually run this, instead of just doing a build, I want a full unit test experience, so I want to run on an iPhone simulator. So we can actually run iPhone simulations in the cloud. I'll do a debug build. And I'm going to add one thing because I'm multi-target. So I'm going to say destination platform option. And I happen to know this. I know this YAML. So you can understand perhaps why we're adding the visual designer back, because this is not super obvious. And I'm going to say publish JUnit results. But the one thing that does help is that this is actually the Monaco text editor. So this is the same text editor here that is in VS Code. So if you're a VS Code user, this auto completion suggestion might look familiar. So we've actually added our YAML description to VS Code and to here. So you do actually get some help. Again, not as much as as bringing the visual designer back. So I'm going to click Save and Run. And what this is going to do now is it's going to queue up a job. And it's going to go and provision a Mac. So again, we've got a bunch of Macs just hanging out, waiting for your builds. It's a mix of Mac Minis and Mac Pros, the old trash can ones, that are this big. If you've ever built a data center, you might think that this much space for a single computer is not super optimal, and you'd be right. That's why we do it, so that you don't have to. In a previous life, I racked a bunch of Macs. I would encourage you to never have to do that yourself. So what it's going to do is it's going to get that Git repository, and it's going to start that build. And again, just like my other project, it's actually set up all of the pull request validation builds and continuous integration builds inside my repository, so that I can always stay healthy. There we go. It's running. Now it's running Xcode. So if I actually go in here, I can actually see it running my test. It's actually going to run the same test as over here, where it cycles through every single tile, looking for that match just to make sure that the game is winnable. And that ensures that anybody who opens a pull request will never break the actual fundamental winning of the game. So it's doing that right momentarily. So you can see it's running the test double tap, it's running the test select matching tiles, then it's running the test tap on visible tile. Is ignored tests. Eventually, it will get to the winning test. Right. In the meantime, let's look at another project. So this is an open source project, again, that I'm the maintainer of. It's called Libget 2. The idea behind Libget 2 is it is a C library for Git repository management. And then on top of that, people add in various, we call them bindings. So if you don't want to write C, because who the hell wants to write C in the year 2019, you can instead add C# on top of this. So there's a layer that just does p invokes down to libgit 2, so that you don't have to, and that gives you a nice C# library for Git repository management. That's called libgit 2 #. There's a Ruby one called Rugged. There's Node-Git that is Node.js. And libgit 2 is used by a number of GUIs that do Git work. It's used by GitHub. It's used by Bitbucket. It's used by Azure repos. So basically anybody doing Git at some point interacts with this library, right? When you click merge pull request on GitHub, it uses this to do it. So it's kind of important that we don't screw that up. And the way that we do that is by having a pretty conservative attitude, but B, a ton of unit tests, and C, a ton of CI builds on top of that for all of the platforms we support. Because on Azure repos, we actually run a cluster of Windows servers to do this work. GitHub runs a cluster of Linux machines. And so we need to make sure that we don't break either of those scenarios. So that's pretty straightforward when it comes to Azure pipelines, right? We've seen Mac builds, we've seen Linux builds, we've seen Windows builds. But it gets a little trickier for Libget 2 because, again, we're just a library that anybody can use. And so if you happen to want to write a Git application for your phone, which, yes, does exist, it's probably more useful on an iPad, I gotta think. But hey, I don't have one of those. There's an app called Working Copy, and it uses Libget 2 to do all that work. And that's really cool. But this is an ARM device. And what Azure Pipelines doesn't have is a bunch of ARM machines hanging out ready to do your builds. But what it does do is give you a real virtual machine to do your builds in. It doesn't, run inside a Docker image where you don't have access to the actual hardware. You get a real virtual machine for every build. And so you can do things like virtualization. And so if we take a look in here in our build description, what we do is we build within a Docker image, and we run this step. I'm not sure how many of you have ever seen this in a Docker image. What it does is it enables QEMU mode. QEMU is a really popular emulator that can target a bunch of other architectures. So by running this Docker command, now I can run what are called multi-arch Docker images. So I can run ARM images. I can run PowerPC images. And so I can actually incorporate other architectures as part of my continuous integration builds, even architectures that Azure Pipelines doesn't have native build machines for. So I can just run this all in QEMU. And so what I actually end up seeing is that our build architecture list starts out really straightforward. We've got AMD 64 for Linux on a bunch of, with a bunch of different compilers. I've got Mac OS. I've got some Windows, AMD 64, Windows x86, both with Visual Studio and with MinGW. And then things start getting a little more interesting. Down here, I've got Linux x86 builds. We only have AMD 64 Linux boxes, and in fact, it's a little bit tricky to get x86 running on them at the moment. So we virtualize this. So we've actually got x86 Docker images that run through QEMU. But the more important part for our friends that are building iPhone apps at least is this ARM32 and ARM64 builds. So if I look at that, what I actually do is, again, I do that register QEMU step. And if you zoom in here, it sets up all of these QEMU targets: ARM, Spark, PowerPC, M68K, S390. So if you want to build IBM mainframe applications with Azure Pipelines, you can. And then it goes ahead and runs that build within a Docker image. So we basically just have a Docker image that is ARM64 with all of our dependencies installed, and we build within that. So you're not limited to just the platforms that we give you, just Mac OS, just Linux, just Windows. And in fact, I mentioned earlier that I kind of like retro computing. So I'm working on some projects, and of course I want a CI pipeline for them. And those projects happen to be around the Commodore 64. If you're as old as I am, this may look familiar. If not, well, this was one of the early microcomputers. Certainly the first one I had in my house, and I think that the first one that many people ever interacted with. Very affordable, very useful, tons of fun. And what this is a Commodore 64 emulator called Vice. And somebody has done terrible things to Vice. What they've done is they've taken it, because it's a bunch of C, and they've run it through a WebAssembly compiler, and out pops a bunch of really disgusting JavaScript, like megabytes of really disgusting JavaScript. But that means I have a Commodore 64 in my browser. This actually works, right? Let me hit reload. There we go, blinking cursor. Right? This is, of course, that was the first program everybody wrote. This is the second, the infinite loop of hello worlds. And so that's fun, right? This is obviously just a gimmick. But my goal here is to not make this a gimmick, to actually make this a useful build pipeline for my project. So let's look at what I've done. Again, I've gone a little crazy with the over-engineering. So this web app is not just Vice running in WebAssembly in a browser. There's actually a .NET Core application here. And what it actually does is, yes, it does deliver that WebAssembly. But if we look at my Razor page, what you'll actually see is it looks for a program, right? So what this is this is a Commodore 64 image of an actual application. If it exists, it will get served up. If it doesn't, you just get the standard old Commodore 64 exactly as you turned it on. For those of you who never experienced this, when you flip the switch on your C64, it comes up and says this. And at this point, you would load something off your tape drives, or something off of a disk drive, which even that sounds archaic at this point. And so what I want to do is actually be able to run the C64 code that I actually create. And so that's what does this. So all I have to do is take my code, compile it into something, name it file.prg in this web app, and it will get delivered up. And so that is here. So here I have some C64 assembly. If you have never written any assembly, let alone C64 assembly, don't worry about it. Again, this is a simple Hello World app in assembly. And let's change our hello. Instead of saying hello world, let's say hello NDC. Cool. Let me just go ahead and check these changes in. Best practice, of course, would be to open a pull request, but let me see if I can shrink this down a little bit. I guess not. Right, so now if I go back, just updated that code, and now let's create a build. So what I'm actually doing is creating a Docker build, very similar to what we did before with our other Hello World application. Oh, whoops. And of course, I forgot, it actually queued one. GitHub did when I actually merged that change. Forgot all about that, wasn't thinking. But let's take a look at what it's actually doing here. So I'm building off of my other Docker image. I'm building a Docker image rather and publishing it up to Azure Container Registry, just like the other one did. I'm also reconfiguring my web application. So I am actually doing a continuous deployment step here as well. Our Hello World app, we just did the build and published to Container Registry. Now we're taking it a step further, telling our web app to run the new container. So that's how we get continuous deployment out of here. And let's take a look while that's building real quick just at the Docker image. Acme. Acme is the name of a C64 cross compiler. So it will take our assembly, spit out hello.prg, and then it will basically take that Cloud 64, that's that .NET Core app with the WebAssembly, and it will lay down, if you're not familiar with Docker files, what it'll do is it'll take the output of the cross compile and put it in as program.prg, and that is the file that our web app is looking for, which will get served up. So, is that done? It is done. Great. So now, if we go here and hit reload, what we should see, while it downloads those megabytes of WebAssembly over conference Wi-Fi, megabytes of WebAssembly. Somebody's session just got out. Everybody's checking their email right now. So what we should see is that it actually bootstraps that WebAssembly, finds the program on disk, and actually, there we go, finds that program on disk and runs it. So let me zoom in just a little bit. And in fact, we got hello NDC. So, no kidding, I am actually using this. I really am playing around with C64s in my spare time, my copious spare time. You have a lot of spare time as a Microsoft employee, it turns out. And so I am check my Twitter. You'll see the crazy project that I am embarking on. And I wish I could take credit for this. I love this. A guy named Tony Landy came up with the idea of using Acme as a cross compiler and using Vice in an emulator, or rather using Vice in WebAssembly for a C64 build and release pipeline. So again, we talk about at Microsoft, at least on my team, we talk about running any build on any platform. DevOps for really absolutely any system. Again, whether that's Mac, Linux, Windows, or iOS devices, or something truly crazy like a C64 or an IBM mainframe. So, if you have any questions, we're really just about out of time. So what I will do is I will actually stick around. I'll stick around here. I'm happy to answer any questions. If you are shy or if you are in a hurry and don't want to hang out and wait, the best way to reach me is Twitter. I'm eThomson. That's Thomson without a P. And I'm happy to answer any questions you have about Azure pipelines, Azure DevOps, continuous integration and continuous delivery, especially for your open source projects, but really for whatever you're trying to build. If you want more information, you can check us out on the internet, or again, just hit me up on Twitter. So, thank you so much. Please enjoy the rest of your NDC.